Wow, it did it again. This video is about Chapter 4, Lesson 4, Linear Functions. And we're concerned about making input-output tables and graphing the linear functions. Problem number 1 says that it's about fuel consumption. The function is d is equal to 18g, describes the distance d that Rick can drive his truck on G gallons of gasoline. It asks us to graph the function. Why is it sufficient to graph this function in the upper right quadrant only? And how far can Rick drive on 2.5 miles of gasoline? Okay, so to graph the function, we're going to do this step by step. There's 3 questions here. There's graphing the function. There's answering why we want to only use the upper right quadrant. And there's answering the question, how far can we go on 2.5 gallons of gas? The first thing we're going to answer is the actual graph itself and the making of the input-output table. So, because that's the main purpose of this section of the book. Okay, so to the input-output table is we're going to put in gallons, and we're going to get out gallons and distance. Okay, and the equation that we're going to use is d of g is equal to 18g. So if we put in 1 gallon of gas, then we'll be able to drive on 1 gallon of gas 18 times 1, which is 18 which is a distance of 18 miles. So the gallon that we're going to input into the equation is 1, and the output of the equation is 18. On 2 gallons of gas, we're going to be able to drive a distance on 2 miles is 18 times 2 is 36 miles is the distance. So we're going to, our input again is 2, and our output is 36. So we will want to plot that coordinate. And we have two numbers real close to the origin here. So we have 1 at 18. So if we're looking at the graph, and again, we're trying to graph this, we have a point here at 118, and we have another point here at 236. At 236. Okay, so we're kind of in here somewhere. It looks as though we're kind of going to be ending up somewhere up in here on the graph. So I'm going to try a point. I want to input 4 because that will tell me the next a point up over here somewhere on the graph. So let's go ahead and jump to number 4 and skip right over 3. And so how far we will go on 4 gallons is going to be 18 times 4 is going to be 72. So when we put in 4, we get 72. So that's going to be the point 472, which is right in here. And so if we connect these points, we get this line here. Okay? So that would be the graph of the equation. And then, and again, we want to put our label on it. So this is d is equal to 18g. Okay? Why is it sufficient to graph this function in the upper right quadrant? Well, the reason is that it doesn't make sense. So like if we're using gallons of gasoline, if we go this way on the graph, that means that we're using a negative number of gallons of gasoline, which is not possible. It's not possible to put a negative number of gallons of gasoline into your car or your motorcycle or whatever. So the thing is the reason that we have to stay to the right of the y-axis is because we can only use a positive number of gallons of gasoline, and we're only going to be able to travel 0 or a positive number distance when we put gasoline in. So we wouldn't, if we put gas in, it's not like we're going to be able to drive a negative distance. That doesn't make sense either. So you can't have a negative gallons of gas, and you can't drive a negative number of miles on that gasoline. So that's why we have to stay completely in the positive on the x-axis, and we have to stay positive on the y-axis. And so that's why we can only use this upper right quadrant of the XY graphing. So the last question is how far can Rick drive on 2.5 miles of gasoline? And to answer that question, we really want to kind of go back to our input-output table, and we want to input 2.5 and into the equation. So we're going to take the distance traveled on 2.5 gallons of gas will be 18 times 2.5. So 18 times 2.5, let me get out my calculator. And let's see, 18 times 2.5 is 45 miles. So this is the answer to part 3, 45 miles. And that answers question number 1. This is the input-output table that created the graph. We have to stay in the top right quadrant because we have to have positive numbers in this situation. And if we put in 2.5 gallons of gas, we get 45 miles traveled out of it. Okay? Problem number 2. It says the function c is equal to 0.5 m plus 1. It describes the cost c in dollars of a phone call that lasts m minutes made from a room at the Shady Tree Hotel. You graph the function. Use the graph to determine how much a 7-minute call will cost. Okay, so problem number 1 is to graph, which means, again, we're going to use an input-output table, which is what we're supposed to be doing here. So minutes are our input. The equation is 0.5 minutes plus 1, and our output is minutes and cost. So minutes will be on the x-axis and cost will be on the y-axis, just like they have listed there. They're giving call lengths. If you look at the graph over here, they're using call lengths of 2, 4, 6, 8, and 10. So we don't want to use other numbers. We want to use their numbers because they're going to help us to solve the problem. With the idea that if they don't, okay, so let's use the 0, 2, 4, 6, 8, 10. So I'm going to start with the 0, and if I put in 0, I get 0.5 times 0 plus 1 is going to be 1. So we get the point 0, 1. So that is this point on our graph. If I put in, I'm going to jump the 4 because it just makes sense. So if I use 0.5, 0.5 times 4 plus 1. Half of 4 is 2, plus 1 is 3. So at 4 minutes, I'm going to pay $3. So at 4, we're going to be at $3 up here. And then I'm going to jump to 8 and see if it stays on the graph. So we get 0.5 minutes, or it's 50 cents for 8 minutes per minute for 8 minutes, plus $1. So half of 8 is 4, plus 1 is equal to 5. That's a 5. And so we get 8, 5. And so if we graph 8, 5, that's going to put us right here. And so this would be our graph right there. Okay? And that answers the first the question to graph the function. It then says something kind of cool. It says to use the graph to determine how much a 7-minute call would cost. So at 7 minutes, we should be right here because this is minutes. And this is 7 between 6 and 8. And if you follow up this line, you get this answer right here. And that answer corresponds with, it looks like $4.50. So the answer to a 7-minute call would be $4.50. And that would be the answer to number 2. Number 3, it says a computer store charges $45 for materials and $50 an hour for service to install 2 new programs and a connection. The cost, C of H, is a function of the number of hours H it takes to do the job. It says to graph the function and how much will it cost for a 3-hour installation? Okay, so what you want to do is we want to create an input-output table. So again, we're going to input H is our hours. Our function is 45 plus $50 per H. And we're going to get out of that H and the cost. Okay? What I'm thinking is, looking at this graph, is I want to plot, I'm thinking 0, 1, 2, and 3 are the numbers to make the math easy. Okay? So, if I put in 0, I get 45. That's a 45. It doesn't look like a 45. But that's a 5. Plus 50 times 0. Well, 40, that'll be 45 plus 0 would be 45. So it's 0.45 for the point. If we put in 1 hour, we're going to get 45 plus 50 times 1. So that would be $95 at 1 hour. If we put in 2 hours, it's going to be 45 plus 50 times 2 is going to, at 2 hours, it will be $145. And at 3 hours, it's going to be 45 plus 50 times 3 would be $195. So we go back over to our graph and we plot 0.45 is right in there. At 1, we're at $95. At 2, we're at $145. And at 3, we're at $195. So this would be the graph of the equation. And then it asks how much will a 3-hour installation cost. And actually that's one of the calculations I did here was 3 hours. And so our answer was $195. So it's $195 for the 3 hours of work. And that is the answer to number 3. Number 4, it says Jonah received $300 in cash gifts for his 14th birthday. The function y equals 300 minus 25x describes the amount y remaining after x weeks if Jonah spends $25 each week. Graph the function and determine the amount remaining after 9 weeks. Okay, so he starts at 300, which is this number here. Okay, he's going to start with $300 in his pocket. And the idea is that as he spends money, the amount of money that he has goes down. Okay, so, and they're going in increments of 4, 8, 12, 16 weeks. So what we want to do is we want to do 300. We want to do our input-output table. Let me make the input-output table again. And we want to, okay, so we have the input is weeks. It's 300 minus 25 times the number of weeks. And we get out of that the weeks and the balance, B. So how much money he has left after the number of weeks. Well, if we put in 4 weeks, we get 300 minus 25 times 4. So that's going to, after 4 weeks, he's going to have $200 because this is 300 minus 100, and that's 200. At 8, so every 4 weeks, right? So every 4 weeks times $25 a week is going to be $100. So we can just go, if we're jumping 4, then we know that we're going to go down 100, right? If we go 4 numbers, we notice that we're going minus another $100. So at 8 weeks, we should be at $100, and at 12 weeks, we should have nothing left in the bank. So if we started with 300, we go down to 2, we go down to 1, we go down to 0. And that's right. That makes sense. So what we want to do then is we want to graph this. At 4 weeks, he should have $200 left. And let me switch to red. At 8 weeks, he should have $100 left. And then at 12 weeks, he should have absolutely nothing left. And then, so that's how you graph it, as you connect all those dots. The next thing is it says graph the function. So that's the answer to the graph. Then it says to determine the amount remaining after 9 weeks. Well, the amount remaining after 9 weeks comes from the equation, okay? And what you're going to do is you're going to plug in 9. So if your equation is 300 minus 25 per week, then you're going to do 300 minus 25 times 9, the number of weeks. So it will be 300 minus $225, which is 9 times 25. So they would have a balance of $75 after the 9 weeks. And that is the answer to number 4. And then the number 5, it says explain how you can use your graph in exercise 4 to determine which week the amount remaining will fall below $190, and then find the week. Okay, so this is actually kind of takes us back to that problem that we did before break, the one with the travel to rent a bike. And remember when we drew a line, if they're saying they want to know when it falls below $190, then we're kind of saying, when does it fall below that number there, below this blue line? So if this is 190, then what's going to happen is we want to know when it's going to be below that. Well, the other thing too is they're going down in $25 increments. So if we're at 200, right? If we're at 200 and we're going down in $25 increments, then the next number down is 175, and then 150, and then 125, right? Each time you're going down 25. Well, they're drawing a line right here at 190. They're saying if this number is 190, how many weeks are left, or what is their question? Then explain how you can use your graph in exercise 4 to determine during which week the amount remaining will fall below 190. So it should fall below between whatever week starts us at $200, and the next week that puts us at $175. Well, right here, we did the calculation that on week 4 we're going to be at the $200. So that means between weeks 4, this is when we're at week 4, and this next number would be when we're at week 5. So somewhere between week 4 and week 5, we are going to fall below the $190. So find the week. It's between week 4 and week 5. Okay. So Ron got a cell phone. Okay, and that's the answer to number 5. And then number 6, it says Ron got a cell phone rate of the cost of the rate is equal to 0.22 plus 0.1 per A. Graph the cost per minute. So I don't know why they didn't use M for minutes. How much will a 5-minute call cost? Okay. Well, the thing is so what we want to do is we want to find out how much it is, like each minute. Okay. And that's easy enough to do. We just have to create an input-output table. And to create the input-output table, we want an X or a minute. Okay. So we want to use minutes. Sorry about that. We want to use minutes. We want to use a function of 22 cents plus 10 cents a minute. And then we're billed on minutes, and that's our cost. So the thing is that so at 1 minute, we're going to pay 22 cents plus 10 cents times 1. So it's 22 cents plus 10 cents a minute. So it's going to be 32 cents for the first minute. For the second minute, it's going to be 22 cents plus 20 cents, right? It's 2 minutes times 10. So on the second minute, it'll be 42 cents. And the next thing they want to know is how much will a 5-minute call cost? So if we go 5, we do 22 plus 10 times 5. Whoops. So we're going to do it's 22 cents to even start the bill going, right? It's 22 cents. And then it's plus 10 cents for 5 minutes. So it'll be 22 plus 50 would be 72 cents. So for 5 minutes, it'll cost 72 cents. And now we want to go back and plot this. So at 1 minute, we were at 32 cents right there. At 2 minutes, we were at 42 cents. At 3 minutes, we're at 52 cents, 62, 72, right? 82. So this is our graph. And they want to know what happens, how much it's going to cost on a 5-minute is right there at 72 cents. And that's it. Man, I hate when